Guys, I wanted to go over the quiz A together because there were a lot of people that made a lot of mistakes. So I thought it would be helpful to you guys to hear me go through the problems and think through them to help you study and review. Remember, if you do better on the test than you did on the quiz, I will replace the quiz grade with whatever % you got on your test. So I'd recommend having your pop quiz handy or your day one notes handy, wherever you wrote down all of these identities. You're going to need them. When I started this quiz, my answer key, I started by brain dumping all of this information down. Maybe not every single thing, but a lot of it, especially the top three Pythagorean identities. Whoops. Try that again. These top three. I definitely would recommend having those written down on your sheet when you go to start your test or quiz. All right, so what I wanted you to do in this first problem, I give you the value for sine, I tell you a little bit about cosine, and I want you to find cosine. The way I wanted you to do this was by using a Pythagorean identity. It's not the only way to do it, but that's the way I'm going to show it today. Because I'm given sine and I'm looking for cosine, I need to use one of these three identities, okay? I'm going to choose the top one because it's a positive in the middle. It's adding, it just makes it a little bit easier. If you choose to use one of the other ones, you just need to be careful with the order of operations and doing exponents before you subtract. So, let's see. I would then take this value for sine, plug it right in. A couple people just literally wrote it down wrong, so be careful with that. It still needs to get squared, so make sure that guy's still there. And then you're going to want to square all of this before you move anything to other sides. When you square a negative, it's a positive. I cannot say that enough. When you square a square root, it's just a 5. Square the bottom is 49. That right there was so many mistakes on people's quizzes. People kept the negative. People put 25 instead of 5. People put 14 instead of 49. All sorts of mistakes in there. Okay. Solving from here, you're going to move this fraction to the other side, subtract it over. You got to do a common denominator, which honestly I don't think was as bad as I was worried about. So that's good news. Let's see, that 1 would become 49 49ths. Subtracts and give you 44 49ths. Keep solving. You got to get rid of the squared. You got to square root both sides. When you square root, you need a plus or minus. We'll come back to that in a minute. Square root this, simplify this. The square root of 44 is going to factor tree or factor ladder. You're going to have a 2 coming out, 11 left on the inside. Square root at the bottom is just a 7. Those outside numbers don't simplify any further. The last thing you got to do is decide on the plus or minus, and it comes back to here. It tells me straight up here that cosine is less than 0, cosine's a negative. I'm finding cosine, that's why I want it to be a negative answer. So that should be your final answer for number 1. You could also think about always sleep through class if that's easier for you as well. And I think we'll do that on the next one. All right, let's look at number 2. Same idea. You are given some information you're given the value for tangent, a little bit of information about sine, and then I want you to find secant. So, because I have tangent and I'm trying to find secant, I need to use one of these 3 identities because they relate tangent and secant together. I had a few people on their quiz try to use tangent as sine over cosine, which is totally true. Tangent is sine over cosine, but tangent is the simplified version of that. So it's not just, oh, -5 is sine and cosine is the 1 on the bottom. Those fractions have been simplified to be -5. So it could have been like -10 over 2 or some fraction over some fraction that gives me -5 when I simplify. So don't use your quotient identities here. You want to use your Pythagorean identities again. So to use the Pythagorean identity, you can use, again, any of these 3 in the orange box. I'm going to choose the top one because it's all positive things. It just makes life easier. And then I'm going to plug in, I know the -5, that's what tangent is. It goes right in there. It's got to get squared. -5 squared is 25. Add those together, I get 26. And then square root both sides because I got to get rid of the squared. Don't forget your plus or minus. I'm almost done. 26 doesn't simplify. There's no pairs to pull out. But we do need to decide between the plus or the minus. And I think this was a little tricky for some of you. I think you forgot to think about always sleep through class. Maybe I wasn't as nice on this as I was maybe on the examples in class, because I was just talking in the directions about sine, not specifically about secant. So if sine is greater than 0, that means sine is positive. That would have to be in one of these two quadrants. And then back here, we had tangent being a negative, so that's going to be in this quadrant because not in the A quadrant. Tangent would be positive here. So if we're in quadrant 2, that tells us that secant, which is the reciprocal of cosine, that's going to be a negative. So that should be your final answer for number 2. All right. Moving on to number 3. This one is where you need to use your negative angle identities. And this was definitely something that confused a lot of students. I knew it was going to be a hard one, but I was unfortunately right. Okay, so what you want to do, if I'm trying to find cosine of negative theta, you need to remember that this rule for cosine of a negative angle, it stays the same. It's equal to cosine of theta. It's equal to the original. It stays the same as the original, as just cosine of just plain old theta. Okay, it doesn't change. So if the answer to cosine is this number, it's going to be exactly the same. It doesn't change. It stays the same. The negative on the angle doesn't make a difference. It's still the same answer. This answer happened to be a negative, so it stayed a negative. Okay, a lot of people thought, oh, the negative on the angle drops, the negative goes away, and so they got rid of this negative. But this wasn't the negative on the angle, this was the negative on the answer. So hopefully that helps a little bit. Feel free to let me know if you have more questions on that you want to go over. Okay. All right, and then the last two, we're going to look at number 4 and number 5. I'm going to pull these Pythagorean identities again on my screen so you can see them. All right, number 4, when you're verifying, you only are allowed to take one side of the equation and make it equal to the other side. You can't move stuff to other sides. You can't square root both sides. You can't do most of it on one side and then a little bit on the other side. You have to do everything on one side. And you want to choose the harder side. I think you guys did a good job noticing that that left side here was harder. There are multiple ways to do this. You can turn this into 1 over sine squared and cosine squared over sine squared. You end up having to do a common denominator on the top and a common denominator for the bottom. It's possible, but it's a lot of work. So instead, take a breath, slow it down, look at this. This should be something you recognize. This is a Pythagorean identity. Cosecant squared theta minus 1 is equal to cotangent squared. I need you to recognize those. I need you to have your little detective badges out and see that guy and use it because it's going to save you a ton of work. Some of you are really going to kick yourself when I show you the final steps here. Okay? That's a Pythagorean identity. And so is this one. 1 plus cotangent squared, it's right here. 1 plus cotangent squared is equal to cosecant squared. seeing those Pythagorean identities is going to save you a ton of work with that common denominator that some of you tried to do. All right? From here, what can we do? Well, changing stuff into sine and cosine at this point is a good idea. That cotangent squared is going to be cosine squared over sine squared. Watch your squareds, don't drop them. And make sure you're not dropping your theta either. Similar idea in the bottom, the purple, cosecant squared is 1 over sine squared. Don't forget your thetas, don't forget your squareds. And now you're almost done. You just gotta flip it. The blue guy stays the same. The purple guy is going to flip to the reciprocal. Now you can cancel out those sine squareds. The 1 doesn't make a difference. Your final answer is cosine squared, which is what you wanted. All right, for number 5, our last one. Again, you can't move things to other sides. You have to show your steps. You have to show your work. Some of you got a little messy with your work here. I was a little bit generous to some of you. I would definitely attack this right side. Because these guys are not squared, this is not a Pythagorean identity at all. So what you could do instead is FOIL it together. Some people turned it into 1 over cosine, which is not wrong. It's just a lot more work. So let me show you this other way, see if it clicks and helps you think of doing it a little bit easier next time. Foiling this will give you secant squared x plus another secant x minus a secant x and minus a 1. Then you've got like terms right here. Oh, a positive and a negative, they actually cancel each other out. All that's left is secant squared x minus 1. Put your detective badge on, look for it. This is something. Secant squared minus 1, where is he? Here he is tangent squared. And that's what you were trying to get. Cool, just that last step is a Pythagorean identity. Okay, a couple people stopped here and maybe they brought down the other side and said, oh, that's equal to tangent squared. You really have to go that extra last step. You have to tell me that this right side equals that, not just bringing down the left side. You have to show me that last step, so make sure you do that. Okay, I hope this was helpful. I hope that you'll take this and do more practice problems, work on that homework, come after school for extra help, ask questions on our catch-up day, whatever it is you need to do, and get yourself ready for that test so that your quiz grade can get replaced with your higher test grade. Thanks, guys.